Welcome everybody to example 5 on the top of page 97 in the workbook. And this is another example of working with the definite integral. It's giving us a function, this time in terms of just a picture, and asking us to calculate the values of some definite integrals. And remember that definite integrals graphically are about area. In particular, definite integrals add area if our function is above the x-axis and subtract area if it's below the x-axis. That's a general principle that we're going to keep in mind as we do these problems. Okay, so let's start with the integral from 0 to 1 of f of x. Our function is positive between x equals 0 and 1, and so we're talking about the area under our curve just between 0 and 1. If we shaded it, it would look like that. And the question is, how much area is that? Well, notice that that's a rectangle that has a height of 6 and a width of 1, so we should just get an area of 6 times 1, which is 6, for our answer. Okay, what about the integral from 0 to 2? Okay, well there, we're starting at 0 and going over to 2. So we're talking about this entire area from 0 to 2. Notice that we've just doubled our area. Now we've got an area of 12 because we've got a 6 by 2 rectangle. Okay, and so 12 is our answer. Okay, what about the integral from 0 to 3? Okay, well now we're talking about the area that we already got, the 12, plus the additional area between 2 and 3 that's under our curve. Okay, so if we shade that, we've just added a little triangle of area. And how much area is contained in that triangle? Okay, well, you might be able to tell from the picture it's going to be half as much area as the rectangle that we have up here, so we should be adding 3. Okay, if you're uncomfortable with that, where that 3 came from, remember, you can go back to geometry formula for the area of a triangle. Okay, I'm just going to highlight that triangle. We made the claim that the area is 3. You could come up with that 3 by using the geometry formula 1/2 base times height. Okay, what is the base of that triangle? Well, from 2 to 3 is 1, and the height you can see is 6. 1/2 times 1 times 6 is 3. That's where that 3 came from down below. And so either way that you think of it, we're going to come up with an answer of 15 for the integral from 0 to 3 of f of x. Okay, good. So let's move on to the integral from 4 to 5 then. Okay, what's interesting about this one is notice that our function between 4 and 5 is down here. It's negative. Okay, so what does that mean again? That the area that we're shading is below the x-axis? Well, it just means that we're going to subtract it instead of adding it. So we're going to get a negative 6 instead of a positive 6 because of the fact that our function is negative. Okay, moving on. We've got a few more to go here. What about the integral from 5 to 8 of f of x? Okay, well that would be referring to this area over here. We're talking about another triangle. Okay, so I'm going to use the geometry formula for this one. Let me ask you this, are we going to get a negative or a positive number for our integral in this case? That area is below the x-axis, so it should be negative, so let's start by noting that. And then we can use the formula for the area of a triangle, 1/2 times the base. The base of that triangle goes from 5 to 8, that's a distance of 3. And what's the height of that triangle? From here to here looks like a height of 6. So put all that together, we should get minus 1/2 of 6 times 3, so 1/2 of 18 is 9. It looks like we're going to get a negative 9 out of that. Okay, we've got 2 more to go here. We've done a lot of drawing on our picture here, so I'm going to just erase what we've drawn so far. Okay, and now let's think about the integral from 0 to 5. Okay, that's a big range of values. We're starting all the way over here at 0 and stopping way over here at 5. So we're really talking about some area that's above the x-axis and then some area that's below it. Okay, so one way to think of this is just to think of it in two pieces, area above minus area below. Okay, and we already know from our previous calculations the area above would be the area from 0 to 3. That's actually this number up here, 15. And then what's the area below? Okay, well, that would be the area of this triangle plus the area of this rectangle. We've already calculated those number a couple of times. And so the area of that triangle is 3 and the area of that rectangle is 6. So we're subtracting 9 because the 6 and the 3 are below. So we come up with an answer then of 6. You can think of that as a net area. We've got a little bit more area above than we do below, and so our net area is positive 6 in this case. Okay, and then finally, what about the integral from 2 to 4? Okay, again, let's get rid of some of the stuff that we drew before. Okay, so from 2 to 4, we are starting here and stopping here. So we've got some area that's above and some area that's below. And what do you notice about those areas? Those two areas are the same, just that part of it's above and part of it's below. So what should we get for an answer here? We should get 0. That's just a reflection of the fact that the area above and below are equal. Okay, and I think we are done with this problem.